We're solving subarray sum equals k, which we're going to try and do with minimum complexity of on time and on space. We're given an array of integers nums and a single integer k, and we need to try and find the total number of subarrays whose sum equals k. A subarray is a contiguous, non-empty sequence of elements within the array. Your options for the optimal solution include A. Binary index tree, B. Sorting, then sliding window, C. Sliding window with a hash table, or D. Cumulative sum. I'm going to pause for a couple of seconds while you consider the best method. So, for those of you who recognize the most optimal solution, congratulations. And for those of you who just want to see some code, the answer here is C, sliding window plus hash table. Let's check out the brute force approach, as given by this hint button. In it, we consider all possible subarrays of the given array and calculate their sum. We can then calculate the number of subarrays whose sum equals k, just using some nested loops. Obviously, the time complexity for this is quite poor because of those aforementioned nested loops. There is, however, a much better way, and that is using the sliding window and hash table. Let's look at our optimized solution. So here, we're utilizing the sliding window technique along with a hash table. We iterate through the array nums and maintain a running sum, which we're calling prefix sum. So it's not a cumulative sum alone. This is, though, another variation of the cumulative sum. However, it wouldn't work without a hash table. For each element, we're checking if the complement of prefix sum minus k exists in the hash table. If it does, we've found a subarray with sum k, and we increment our result counter by the value stored in the hash table for that complement. Finally, we update the hash table by incrementing the count for the current prefix sum. This approach allows us to find the total number of subarrays with sum k in a more efficient way compared to the brute force approach. However, I can appreciate that that's quite difficult to understand, so I'm going to go through this line by line to ensure full understanding here. First of all, we're creating this unordered map in C++, which stores the prefix sums as keys and their frequencies as values. This is initialized with a key value pair of 0 and 1, representing an empty subarray with sum 0. This helps handle cases where a subarray starting from the beginning has sum k. After that, we're initializing the variable sz to store the size of the array, result to keep track of the total number of subarrays with sum k, and prefix sum, which keeps a track of the running cumulative sum. After that, we iterate through the nums array using this for loop. First of all, we update prefix sum by adding the current element, nums_i. Then, we check if my map contains the complement of prefix sum minus k. If it does, it means we found the subarray with sum k. We increment result by the frequency of that complement in the my map. We then update the frequency of the current prefix sum in my map by incrementing its value, like so. Once we've done all that and we've iterated through the entire array, we can simply return the result, which will be the total number of subarrays with sum k. I hope that that's helped you, and just to ensure understanding here, I'm going to show you once again the problem and the possible solutions. You have 4 options: cumulative sum, sliding window plus hash table, binary index tree, or sorting plus sliding window. Obviously, it's the sliding window plus hash table. Maybe it's not so obvious if you haven't watched the video. If you want the reason why, our application will explain briefly why this method is considered more optimal than the others. If you click on any of the less optimal answers, you'll get an explanation explaining why they are less optimal too. For those of you who prefer alternative languages, we also provide the solution code in Python and Java as well. I hope that that's helped. This is I think it's one of the more common coding interview questions, or at least it is according to the course that I recommend. I finish as always by recommending you check out the Udemy course, which is listed in the description to this video. Dr. Ibrahim offers a more comprehensive and visual explanation than the one we're providing in this YouTube video, which is designed to accompany our application. You should have found this by clicking on the YouTube video here. In any case, thank you very much for watching.